All right, ladies and gentlemen, welcome back to another round of information for pre-AP chemistry. Today, we're going to take a look at properties of matter. The first thing I want you to get down in your notes, number one, properties are descriptions. Properties are descriptions. Properties are descriptions. Properties are descriptions. They are passive descriptions. Think back to your English class, the difference between a verb and something else, right? A verb is an action. These will not be actions. Properties will be descriptions. The context of the way they're doing that will be a passive context, all right? There are two types of properties that you are going to have to know. And I'm going to abbreviate that, PROP. There's two types of properties. The first is going to be a physical property, and we're going to talk about those a little bit later. All right. The other is actually a chemical property, and that's where we're going to start today. So chemical properties are descriptions of how something will react. It's exactly what it sounds like. Your chemical properties are just going to tell us how something reacts, whether something is corrosive. What that means is that it's actually going to eat something away. It's going to decompose it. Whether it is inert, the term inert, which is INERT. All right, so when I say something is inert, I'm going to tell you it's not reacting at all, or it's not going to react at all. All right, which is actually in and of itself, even though it's not telling me how something will react, it's telling me that it will not react, which kind of falls into the same category. Other examples that you might see are flammable, and that just tells me whether something would catch on fire at any particular temperature or in an open flame, whether something is an oxidizer. And we'll talk about oxidation reactions, but normally if something's going to oxidize, what you think of oxidize right now would be something rusting. So an oxidation reaction, at the very beginning of understanding of oxidation reactions, it's easy to think of, normally it's some kind of reaction with oxygen. That's not always the case, but normally you think of, like if you put a piece of metal out in the rain or something like that, it's going to oxidize. It's not the water that actually oxidizes it. It's the oxygen in the air that does, all right? And then another one, combustibility, like whether something's going to explode or combust on us, all right? All those, if you really wrote those down, are passive descriptions of how something will react. And I only wrote one example down, but I gave y'all 4 or 5. I want to make sure that you get those examples down. And if you didn't, go ahead and pause the video right now, back that sucker up, and get those things down, all right? And I also gave you descriptions of what each of those things are, okay? So make sure that you're getting everything down in your notes that you need to get down, because otherwise you're going to struggle, all right? Okay, so now let's jump on to the physical property side. So physical properties are just going to be our physical descriptions of our matter. Now, our physical properties, and I'm going to go ahead and clear the screen here, and I'm just going to focus on physical properties, because physical properties we can actually delineate into 2 different types. And so if we have physical properties up top, we can actually break them down into 2 different classifications. One would be intensive physical properties, and the other is going to be extensive physical properties. And so I'm going to go over here to the right-hand side. We're going to start with extensive properties. And extensive, the easiest question that you need to associate with that is how much. Right? Because an extensive property, the property that we're looking at, again, it's a description, but it will actually change if I change the amount of the substance I'm taking a look at. All right? And these are usually measurements. It's something you want to get down. They're usually measurements, and their examples would be things like, they would be like mass, right? How much something weighs. They would be volume, right? And we understand mass. If I put more of the substance on there, then it's going to weigh more. Like if I'm looking at just copper wire, if I put more copper wire onto the scale, it's going to weigh more, right? And we all kind of understand that, but we never associate it with extensive property, all right? Volume's the same way. If I'm taking a measurement of water, if I put more water in there, it's got more volume. And so again, extensive property, normally measurements, and it's things like mass, volume. Another example would be length. And then a big one for us is going to be number of moles, right? And the moles is going to directly describe the number of atoms or elements or compounds that are present. All right, and so those are your 4 big examples of extensive properties. Again, you look at that stuff and you understand, hey, that's how much of something I've got, right? Now, there is one trick here, is that measurements that are ratios, measurements that are ratios are intensive. And an example that I can think of off the top of my head is density, right? Density is a mass divided by volume ratio. Notice I've got 2 extensive properties in there, but they exist in a ratio as a fraction. And so what that does, if I change the mass, I also change the volume, right? And so it doesn't matter. It's not going to change the density because both change proportionally. So if you have these extensive properties as a ratio, they're actually intensive properties. So don't get confused by that. If I'm just looking strictly at mass, volume, length, number of moles, I'm looking at extensive properties. If I'm looking at a ratio like density, it's an intensive property, okay? So intensive properties, let's jump over here. Intensive properties, it doesn't matter how much you've got. Like if you have a blue shirt on, it doesn't matter if I make the blue shirt bigger, it's still a blue shirt. The blue is the blue is the blue. All right, so intensive properties, they don't matter. The memory trick for this that I tell most students every year is just memorize what the extensive properties are. There's only a couple of them, right, that you're going to have to be familiar with. The intensive properties, man, there's a long list of these things, all right? And it's hard to memorize all of those, but it's one of those memory tricks. If you have something, it's either going to be one category or the other, and you memorize the small category and just understand that everything else fits in the other. All right, and so that'll reduce the number of things you actually have to try to memorize. But I'll give you some examples, right? An example would be whether something was a solid, a liquid, or a gas. And this letter right here that I'm looking at, it's not an E, that is an L. All right, so whether something's a solid, a liquid, a gas, so a state of matter. Another example would be like boiling point or melting point, and so that would be exactly what it sounds like. At what temperature does something boil? At what temperature does something begin to melt? Some other common examples would be malleability and ductility, and both of those deal with how I'm going to be able to shape wire or metals, right? Malleability is whether I'll be able to beat it out into a flat sheet. Ductility is whether I'll be able to draw that particular metal into a wire, right? So you understand most wires in your wall are made of copper or aluminum, right? Copper and aluminum are very ductile, all right? And the other examples, odor would be an example. Now, odor's a tricky one because some people say, well, if I have more of it, it's going to smell stronger. I'm not talking about the intensity of smell. I'm just talking about what something smells like, right? Like if I said banana, you could probably close your eyes and picture in your head what a banana smells like, right? So the odor itself is an intensive property. The other one that may not be as obvious is magnetism. Whether a metal is magnetic or not is an intensive property. It doesn't matter how much of the metal I've got, it's still magnetic, right? Or it's not magnetic, whatever it is. And then another one that I gave you over here is density. And that's one of the tricky ones because it is a ratio of your extensive properties, but that does make it intensive. All right? Okay, so big thing to catch out of this, ladies and gentlemen. To wrap it up, man, I'm just going to tell you physical properties, chemical properties, they are descriptions. They are descriptions. They are descriptions. Our next lecture is going to be about changes. And guess what changes are going to be? They are going to be actions. All right, but just please understand, properties, they are descriptions. It's a passive context. All right, so hopefully you got everything down. Get your questions, bring them to class so we can get those taken care of, or come to tutorials and get them answered beforehand. Make sure you get your summary done, and I will see you in class.